Alright, it's me. Another day, another Leetcode. We will be doing the ugly number. What makes it ugly? I have no fucking idea. But we will do this question anyways. Ugly number is a positive integer whose prime factors are limited to 2, 3, and 5. Given an integer n, return true if it is an ugly number. Okay. Return false because I only want to check if it's true based on the conditions of n. N%. How would I check prime factors? I would need to get all the factors of 14. How do I find all the prime factors? Prime factors. So basically, how would I exhaust all of this? How would I exhaust all of this? I need to figure out all the prime factors of a number. So that'd be 6 divided by 2. I'm given the number itself. How do I find all the factors of a number? Oh, n can be negative too. I could use recursions. I could keep doing a percent 2, 3, or 5. One has no prime factors, so for all its prime factors, 1, 2, 3, 5. Okay. So I can make a base case for 1. Return true. If n equals 2, I'm going to create a helper function. What this helper function is going to do is it's basically going to just recurse. And if the number is ugly, what I'll do is helper accept n as a number. So I'll accept the number. And then what I'll do is, so I'll define helper def. Fuck, my rib is killing me. I got punched so many times. But that's part of life. That's part of life. Helper num. What I'm going to do now is I want to check if it's a prime factor. So all I have to do is keep dividing if num percent 2 while num is not equal to 0. If num percent 2, the remainder is 0. Num equals num divided by 2. And then I'll repeat this for all the ugly number factors. So for example, I can do this. So I'll do for 3 and 5. And the reason I do this is because it'll keep repeating itself and eliminating these factors until it finally hits something that's not. So I want to eliminate all these, elif, elif, elif. So what I'll do is 2, 3, 5. And then I want to continue because I don't want it to go to the rest. Actually, wait. If it's already doing that, if it's an elif, so it doesn't go. It's only if this one doesn't fail. So then it goes elif, elif, else. And then I put break. Else. If it's an else, return false. And if it makes it out, if it finally makes it to 0, return true. If it makes it out, return true. If it hits an else condition, it shows that there's no other prime factor. And then I return helper in. Okay, 6. Output is false, expected true. 6 divided by 2. Let's try this. Expected true. While num is not equal to 0, I take the number, I check if its remainder is 0, then I divide it by that, eliminate this factor, continue. Check it again, 2, no. Is it 3? No, let's say it's 5. Okay, now I go again. If 5 isn't, if it's not this, and it doesn't produce a remainder with these 3 of 0, it should return false. Otherwise, repeat the cycle, right, until it hits 0. And when it eventually hits 0, return true. How does 6 not work? While num is not 0, okay, so 6 is not 0. 6 divided by 2, 0 remainder, so divided by 2 is 3, right? Divided by 3, I get a remainder 1. So if num equals 1, return true. And if it's none of these, return false. This should try that. Yes. No, what the fuck? What the fuck? 1,012 out of 1,013 test cases. Why? Why does it edge me like this? Why are you fucking edging me like this? Oh, if it's a 0, if n equals 0, output is true, expected false. Okay, I could work with that. If oh yeah, because factors all return to 1. So I could delete this in theory. Boom. It's your fucking boy. It's your boy. It's your boy. It's your boy. That's just understanding mathematics, right? Because all factors return to 1, right? Because if you divide everything, divide, right? You're left with 1 at the end after you remove everything, right? Because how else, if it was 0 at the end, like none of the other factors would exist because anything times 0 is 0. So you have to have 1 as a base. That's why when you get n equals 1, it's true. And whenever you try to reduce these, right, you get false. And then I could put return false here because if it does equal 0, you want to get false. But like you'll never get that because the fact that it passes these preliminary checks will already do that for you. The reason I have to redo 1 again is because if I get n as 1 on its own, I have to return true, right? But if I get something that reduces to 1, then I return true here, else return false here because there could be another factor. See what's going on here? See what's going on? Right, so it'll either reduce to 1, right? Or it'll hit a condition where it doesn't meet any of these. It's not any of these. So then if it's not any of these, by default, I just want to end, right? You don't even need to know what the exact number is. So if you like that, give it a thumbs up, subscribe, and comment below. It's your boy. It's your boy, the Canologist. Peace.